This video is all about transforming graphs with the modulus function. But first, just a quick recap of transforming graphs from year 12. When we have a plus a outside the function, we know that affects the y coordinates only, and we add a to each of the y coordinates. The effect that has on this graph is it's going to move everything up by a squares. So the graph is going to move up like this. Or if a was negative, it would move down like this. Next transformation, if the a was on the inside of the function, of the brackets, it affects the x coordinates only. And we do the opposite. So I would subtract a from all of the x coordinates, which would move the graph in this direction. So it's going to move horizontally like this. Unless, of course, the a was negative, in which case it would move in the positive direction. Next, if I've got an a at the front there, that's multiplying the function. It's multiplying all the y coordinates by a. So the effect that's going to have is it's going to stretch this graph out by a scale factor of a in the y direction. So it's going to look something like this. Next, if the a is on the inside of the function, like that, that's multiplying on the inside. That affects the x coordinates only, and we do the opposite. So we would divide all the x coordinates by a. So that's going to squash the graph in horizontally. So it's going to look something like this. Then we've got the two reflections. If the minus is on the outside, that's going to be a reflection in the x-axis. So it's going to look something like this. And then finally, if the minus is on the inside, that's going to be a reflection in the y-axis. So that's going to look something like this. So those are all the transformations you should hopefully remember from last year. The two new ones for this video are: what do we do if we have a modulus on the outside of our function? And what do we do if we have the modulus on the inside of the function? So let's have a look at both of those now. So first of all, if we have the modulus on the outside, which we have kind of seen a little bit already. So what we're doing here is we're substituting x values into our function here, and then we're getting the y values out. So when I substitute 3 into my function, I get 6 out. So 3, 6 is roughly there. When I substitute 2 into my function, I get 0 out, which is roughly there. When I substitute 1 into my function, I get minus 1 out. When I substitute 0 into my function, I get 1, and so on. My point minus 1, 2 is roughly there. The point minus 2, 0 is roughly there. And the point minus 3, minus 9 is roughly there. Now, when the modulus is on the outside of the function, I'm substituting the x values in as usual. So I substitute 3 in and get 6 out. And because 6 is already positive, the y does nothing to that. The modulus does nothing to that. The modulus of 6 is 6. Similarly, the modulus of 0 is 0. But then we have the modulus of minus 1. The modulus of minus 1 is plus 1. So that's our first change. This point that was here is now going to move up there. Then the modulus of 1 is 1, the modulus of 2 is 2, the modulus of 0 is 0, And now we have another change over here. The modulus of minus 9 is going to be positive 9. So the point that was down here is now going to move up there. So basically, these bits of the graph that were positive before, so this bit of the graph is positive, this bit of the graph is positive, they don't change at all. They stay exactly where they are. But the bit of the graph that was negative, this bit here, reflects to be positive now. And this bit down here, that also reflects up here to be positive. So just to summarise that, the modulus on the outside makes the y values positive. So we are just going to reflect any negative y in the x-axis so they become positive. Let's have a look at a few quick examples. So this part of my graph, that's positive. That stays exactly as it is. That's not affected at all. But this part of my graph down here, that's currently negative, so I'm going to reflect that up to be positive. Done. This part of my graph and this part of my graph are both positive, so the modulus on the outside does nothing to those. Those stay exactly as they are. And a bit of the graph that's negative here, the modulus on the outside is going to turn that positive, so that reflects up to be like that. And third example for this type of transformation. Here's positive, so those parts of the graph are not affected at all. They stay exactly as they are. So that stays as it is there, that stays as it is there. And then this little bit of the graph there, that's negative, so that's going to reflect up to be positive now. And this part of the graph down here, that's also negative, so that's going to reflect up there to be positive. So that's if the modulus is on the outside of the function. What about if the modulus is on the inside of the function? So we need to be quite careful here. So same idea, I'm going to talk you through this table of values and then what that transformation does. So previously when I substituted 3 into my function, I got minus 6 out. So the coordinate 3 minus 6 is down there somewhere. When I substituted 2 into my function, I got 3 out. So that's roughly there. When I substituted 1 into my function previously, I got 1 out. So that's roughly there. When I substituted 0 into my function, I got minus 2 out. So that's there. And so on. Minus 1 minus 3 is roughly there. Minus 2 minus 1 is roughly there, and the coordinate minus 3, 9 is roughly up there. So that's the original function. Now, this modulus on the inside here, what that does is that turns the x positive before it gets substituted into the function. So that order is really important. The x becomes positive and then it gets substituted into the function, and so could then become either positive or negative afterwards, as long as it's positive before it gets substituted in. So when x is 3, the modulus of 3 is 3, so the modulus did nothing to that, 3. Substitute that into the function and I get minus 6 just as before. Just to repeat that, if I substitute 3 into this function, the modulus of 3 is just 3. And so substituting 3 into my function gives the same y value of before, which is minus 6. And that same logic is going to apply for when x is 2, when x is 1 and when x is 0. Those values are going to be exactly the same as before because the modulus does nothing to those values. So this part of my graph is exactly the same. Now the big difference though is going to be now when I get to these negative x values. So if I substituted minus 1 in, the modulus of minus 1 is plus 1. So that's the same as me substituting plus 1 into the function, which is the same as what I had over here. So I'm going to get 1 back. Similarly, if I substituted minus 2 into my function, the modulus of minus 2 is plus 2. So that's going to give me the same result as when I substituted plus 2 into the function. So I'm going to get 3 back. And then the same thing for the minus 3 on the end here. I'm going to get the same thing as when I substituted plus 3. So I'm going to get minus 6 out. So what we're saying then is that this part of the graph won't change at all because the modulus has no effect to the positive x values. So this part of my graph was exactly the same. And then the negative part of the graph, well, that's exactly the same as the positive part of the graph over here. It's a reflection in the y-axis. So I am ignoring completely the left-hand side of this graph. I'm not plotting that at all. And I'm replacing it with the reflection in the y-axis. And so that's my summary for this transformation. It makes the x positive, then substitute in. The effect of that is I've removed the left-hand side of the graph, the negative part of the graph, and then I reflect the positive part in the y-axis. So let's have a look at a few examples of this transformation. So this part of the graph stays exactly as it was before. So that's exactly the same. This part of the graph, get rid of it, don't need it anymore. I'm just going to reflect in the y-axis. This part of the graph stays exactly as it was before. This part of the graph, ignore it completely. We're going to reflect this in the y-axis, so it's going to reflect up to be like that. This part of the graph stays exactly as it did before because the modulus does nothing to those positive x values, so that stays exactly as it is. We get rid of this part of the graph, we don't want that at all anymore, and we're going to reflect all of this in the y-axis, so that's why it goes up here like this. Right, let's draw these out for myself now. Let's look at both of these things together. So on the left-hand side here, I've got the function given to me like this with a turning point at 2 minus 4, another turning point at the origin, and a x-intercept at 3, 0. First of all, I'm going to draw where the modulus is on the outside, which means the y values have to be positive. So this part of the graph is not affected at all. That's going to stay exactly as it was, because that's already positive. But all of this is currently negative, so all of that is going to flip and become positive, so it's going to look something like this. So my graph's going to come down to the origin, it's going to go up to the turning point, which I'll talk about the coordinate of that in a minute, down to the point 3, 0, The turning point here is now the coordinate 2, positive 4. It was 2, negative 4, but we've just turned it positive. So it'll be 2, positive 4. Let's now draw the graph where the modulus is on the inside. So that's affecting the x coordinates. The positive part of the x graph, this part here, will be exactly as it was before, because the modulus does nothing to that part of the graph. So let me draw that in. Coming down to the point 2 minus 4, up through the point 3. Then the negative part of the graph, that's gone completely. And I'm just going to reflect this in the y-axis. It's going to look something like that. It's going to come down to the turning point. The coordinate of that turning point is minus 2, minus 4. Just reflecting this in the y-axis. So the y coordinate, the minus 4, is not affected at all. The x coordinate was 2, has now become minus 2. Similarly, my intercept on the x-axis there is then going to be minus 3. Next example. Again, on the left-hand side, I've got y equals f of x. We've got a quadratic that's going through the point 5, minus 1. Those are the x-intercepts. It's got a y-intercept of minus 5, and we've been given the turning point there. And I want to draw the graph of the modulus of f of 1/2 times the modulus of x. So let's go through this stage by stage. I'm going to focus on the inside bit first. So I'm going to draw the graph of the modulus of f of the modulus of x. So that's where the positive part of the graph, this bit of the graph here, is unaffected. So that's going to look exactly as it currently does. I know this is the point minus 5. This is the point 2 minus 9. This is the point 5. And now I'm going to reflect that in the y-axis, which is going to look something like this. That's minus 5. This is the point minus 2 minus 9. Now I'm going to deal with the 1/2 on the inside here. So that's going to affect the x coordinates, and we're going to do the opposite. So rather than halving all the x coordinates, I'm going to double all the x coordinates. So that 5 is going to become 10. The 2 minus 9 is going to become 4 minus 9. The y-intercept is not going to be affected at all. The minus 5 over here is going to become minus 10, and the other turning point is going to be minus 4 minus 9. And it's going to look something like this. Let me rub out this red line here so we don't get confused. We've now got one extra transformation still to do. We've got the modulus on the outside here, which I know is not going to affect the positive part of the graph here or here. They're going to stay exactly as they are. But all of this part of the graph that's currently negative is going to reflect up to be positive. We've got the turning point here, which is minus 4, positive 9 now. The y-intercept here, which is positive 5 now. And the turning point here, which is positive 4, positive 9. And so that shape there is my overall answer for this question involving those 3 different transformations. And let me just tidy all that up. So when you've got more than one transformation, just do one bit at a time, and that will make it easier for you. Last couple of examples. So again, transform the original graph on my left-hand side there. We've got a cubic graph with two turning points, P and Q. First, I'm going to deal with the minus on the inside here. So that's a reflection in the y-axis. So point Q is going to move over here to be at -3, -2. Point P is going to move here to be at +1, +3. So it's going to look something like that. So that's dealt with the reflection in the y-axis. Now we're going to deal with the modulus on the outside, which means the y-coordinates always need to be positive. So this bit of the graph stays exactly as it is. So does this bit here, stays exactly as it is. It's this part that's going to reflect up to be here now. And this part of the graph that's going to reflect up to be there. The point Q is going to move now to be here, which is the coordinate -3, +2. And so this is my final answer. And then finally, we've got 3 transformations going on in this last question here. We're going to deal with the modulus on the inside first. So that's going to keep this part of the graph exactly the same. So let me draw that in first. Point Q stays at being 3, -2. We're then going to reflect that in the y-axis for the next part of for the negative part of x. So point Q has got a reflection at -3, -2. Next, I'm going to deal with the fact that we've got this negative at the front here. So that's a reflection in the x-axis. So reflecting this graph in the x-axis is going to look something like this. Point Q, this point is now -3, +2. This point over here is 3, +2. And then finally, we have got the +2 on the end there. That's going to shift the whole graph up 2 squares, 2 units. So the whole graph's going to look something like this, where I've got the point Q -3, 4, and 3, 4. And there we go. That's how we do it with combination of transformations. But the main point from the video really is this idea of the summary here. If the modulus is on the outside, then you reflect any negative y in the x-axis, so they're positive. If the modulus is on the inside, then we remove the left-hand side of the graph completely and reflect the right-hand side in the y-axis.